Delaware Tech, Chemistry 100, Chemistry 110, polyatomic ions. Polyatomic ions are groups of atoms that are bound together to form a single ion. So this is an ion composed of multiple atoms. Usually these are different types of atoms, at least two different kinds of atoms, but not necessarily. And they hold a charge and they stay together very frequently during chemical reactions. Not always, but most often. And because they form an ion, these are typically found in ionic compounds. So even though the atoms within polyatomic ions are covalently bound, please do not let that confuse you. If you see polyatomic ions, chances are it's an ionic compound, and you will use the rules for ionic compounds. So let's take a look. So polyatomic ions are, as I mentioned, are groups of atoms. They can carry a charge, a positive charge, or a negative charge, and we have examples of -1, -2, -3, as well as +1 charges. There are a variety of charges that are available to polyatomic ions, and they're quite a large number. We're going to go through a handful of them right here. The first two I'll talk about are hydroxide and cyanide. And unlike all the other polyatomic ions that are in this list today, they all the others end in ite, I-T-E, or ate, A-T-E. These two are the oddballs. So hydroxide is OH with a negative charge. So this is an oxygen bound to hydrogen with a negative charge overall. And people write it OH minus or HO minus, usually the first way, but the second way is perfectly acceptable. And cyanide is always written CN minus, because if you write it the other way around, it's actually a slightly different ion called isocyanide, which we are not going to talk about today. So here are the first two, and they're both -1 charged polyatomic ions. We also have a pair of ions called nitrite and nitrate. And you'll notice they have similar formulas and, again, a -1 charge. Nitrite is NO2, 1 nitrogen, 2 oxygens, with a total negative charge over the whole ion, over the whole polyatomic ion. And nitrate has 3 oxygens. And what you're going to find is this pattern of ites and ates. You're frequently going to see these come in pairs. And the nomenclature that's used to describe the pairs is this. If they have a lower number of oxygens, we call it the ite, and if they have a higher number of oxygens, we call it the ate. Now, don't let that confuse you, because sometimes the pairs may have 3 and 4 oxygens, so 3 is the lower number and 4 is the higher number, so don't let it throw you. The lower of a pair is ite, the higher of the pair is ate. We also have acetate. Acetate is what we call an organic ion. This is one that's carbon-based. That's what organic means to a chemist. It means it's a carbon-based compound. It contains 2 carbons, 3 hydrogens, and 2 oxygens with an overall -1 charge. And there are many ways to write the acetate ion. So I'm showing you 2 of the many ways. An organic chemist might write it as CH3, because the 3 hydrogens are all attached to one of the 2 carbons, and then the 2 oxygens are attached to the other carbon. So we write it CH3CO2 minus. We might actually also write it CH3COO minus, knowing that both oxygens are attached to that second carbon. So there are a lot of ways to write it. I will restrict my ways to one of these 2 here. Permanganate. So this also ends in ate, and you see there are a lot of oxygens on this one. This is manganese metal with 4 oxygens on it, and to have an overall charge of -1. The per prefix actually is short for hyper, meaning a lot or an excessive number. So this is an excessive number of oxygens for the manganese series with oxygens. It's the most that it would have. 4 oxygens for that particular one. We also have chloride and chlorate. Again, another pair of ite and ate, ClO2 minus and ClO3 minus. But what's interesting about chlorate and chlorite is there are actually 2 other common chlorine-oxygen polyatomic ions. One with even less oxygens, called Hypo Chloride, the hypo telling you it's even less than the chlorite, 1 oxygen, and perchlorate, meaning there's even more oxygens than the regular chlorate, in this case 4. So this kind of matches the permanganate I showed you, but again, series are different for each group of atoms, so you have to be very careful. You'll notice that all of the ones in any grouping like this of the itonates, they all have the same charge. In this case, that charge is -1 for all 4 of them. And the fact is, you can make the same collection of 4 with chlorine, as is shown here, but you can also do it with bromine, and you would get hypobromite, bromite, bromate, and perbromate if you just replace Br for Cl. And you can do the same thing with iodine and have hypoiodite, iodite, iodate, and periodate with I instead of the chlorine. So be aware of all those other possible combinations. So let's move on to some of the -2 charged polyatomic ions, sulfite and sulfate. So now you'll notice sulfite and sulfite pair have 3 oxygens and 4 oxygens respectively. So you can't go by the itonate to tell you how many oxygens there are. Unfortunately, you just have to remember it. So in this pair, we have another pair, and this is a slightly different way of pairing. This is not the same itonate pair. This is chromate and a double of chromate called dichromate. It's almost double. It's double with 1 oxygen missing. So instead of CrO4 with 2 negative charges, it's Cr2, 2 chromiums, with 7 oxygens, but still 2 negative charges. So the groups tend to have the same charge, whatever the charge is, but it may be different for each group. We also have carbonate. Carbonate, I'm sure you've heard of. Carbonate is CO3 with a -2 charge also. So let's move on to the -3 ones. We have phosphite and phosphate, and this can be confusing because phosphite and phosphate have the same number of oxygens as sulfite and sulfate, but they have different charges. So the phospho groups tend to be -3 charges, whereas the sulf group, the sulfur-based ones, are -2, and the nitrate and nitrite are -1. So you have to be careful which group or which charge when you're memorizing these. Now, in addition, we can also take these polyatomic ions that have more than 1 negative charge and start loading them with hydrogens. Not just plain hydrogen, but an H+ ion. So if you add an H+, a hydrogen ion, to carbonate, it takes away one of the negative charges, so you end up with hydrogen carbonate, HCO3-. And hydrogen carbonate you may not have heard of, but you've certainly heard of the old name for hydrogen carbonate, which is still used quite commonly, bicarbonate. In fact, you can buy sodium bicarbonate in the store. It's part of both baking soda and baking powder, as a matter of fact. We can do the same thing with phosphate and phosphite. Phosphate, much more commonly, you can add 1 hydrogen to phosphate, it's an H+ we're adding, so we're taking away 1 negative charge to make HPO4-2. And then we can add 2 hydrogens to make dihydrogen phosphate. That's H2, the dihydrogen, 2 hydrogens, PO4 with only 1 negative charge. And I don't write the 1 in any of these, you notice. You can write the 1, that's perfectly fine, but most chemists don't bother writing the 1 when they don't have to. In addition to all of these negatively charged polyatomic ions, we have a couple positively charged ones that you need to know for this course. You'll need to know the first one for this unit and the next unit, especially when we're starting to do nomenclature, and the second one, hydronium ion, is going to become extremely important when we get to the acid and base unit. So ammonium is derived from the compound ammonia, NH3. NH3 is a neutral compound, but if you add an H+ ion to it, just like we did before, it adds not only the H, but it adds a positive charge, making ammonium ion. And you can tell the positively charged ones, they end in ium, I-U-M, whereas all the polyatomics end in ite or ate, with 2 exceptions, hydroxide and cyanide. So ammonium, NH4+, is a cation, and you will find it in some ionic compounds that don't even have metals. It will act as the cation in that ionic compound, so be aware of that when you start learning the naming rules, the nomenclature rules for naming compounds. Hydronium ion is H3O+, and we get hydronium ion by adding H+ which is the ion we've been talking about here, H plus ion, also known as a proton, because H atom, the hydrogen atom, is usually just a proton in the nucleus with no neutrons most of the time, and an electron in the electron cloud around it. Well, if you make a positively charged ion of H atom, you become the hydrogen ion, the H plus ion, really is only the proton left over. So we call we call the hydrogen ion a proton. So when a proton is added to water, H2O, you end up adding an H plus to H2O, so you end up with 3 hydrogens, the 1 oxygen you always had, and now a positive charge, H3O plus hydronium ion. Don't confuse this with hydroxide ion right at the top. Hydroxide ion, by the way, you get by removing a proton from water, which can happen in some circumstances. So hydroxide, you can get it from removing a proton from water. Hydronium ion, you can get it from adding a proton, an H plus, to water. And with this, we'll stop here.